Hello, everyone, and thank you for your patience. The press conference is over, and lucky for us in the Netherlands, some good news. So some of the measures are being lifted. So yeah, things are looking pretty positive for us right now here in the Netherlands. So I hope everyone else can enjoy that soon as well. So yeah, apologies for the late start, but let's get started. I just want to do a short introduction. This is one of the first virtual meetups we're doing, and yeah, we're gonna try it out, see if it works. What I want to say is that every week we now have a virtual meetup coming up, at least for the next couple of months, until all the Corona stuff is gone and we can finally meet in person again. Until then, I love seeing you guys online, which is great. These are the 3 upcoming events after this one. If you want to check out other meetups, you can always go to our meetup website or join the conversation. Join us on Slack and join 1,500 people, and building apps. And so with that, I'd like to give the floor to Maarten.
Yes, thank you, Jan. And I will share my screen.
Hey, when we talked this afternoon, you had a nice beach in the background. What happened?
Yeah, I moved to my home situation. Okay, so hi everyone. Welcome to this online meetup. Together with my colleague Timon Kupers and our CTO from TimeSeries Jethro Borsje, we're gonna try to entertain you this upcoming hour and a half. For those of you who don't know me, my name is Maarten Bongers. I'm a Mendix consultant at TimeSeries, and I will be your meetup host this evening. And we'll do this evening a little bit in a theme, which is healthcare. And why healthcare? Well, at the moment we're all at home thanks to or due to Corona, and not the beer kind of Corona, but of course the disease. And that's why healthcare is a big issue at this point. And innovating in healthcare is also something lots of people are talking about and thinking about. So that's why we want to share some thoughts with you guys. And also staying healthy at home is a big issue, and we also have some tips and tricks for you guys at home to keep your mind and body fit. So what are we going to do? At first up is my colleague and CTO Jethro Borsje, who will be talking a little bit about smart rostering in healthcare. It's one of our new solutions. It's going to talk about the functionality, architecture, but also showing some stuff in Mendix and how you can go about creating such a solution. After that, Timon Kupers will talk about staying healthy at home. The fun thing about Timon is that he's not only a Mendix developer, but he's also a professional athlete who should have gone to the Olympics this summer, but they're canceled or postponed. And after that, we have a very fun and very great quiz about Mendix to keep your brain fit and healthy. And there's also a really good prize. There's a nice fitness watch to win. So the more reason to stay tuned and try to be the best. So for now, just to start, I will pass on the word to Jethro Borsje, our CTO.
Hey guys, and if you have any questions, you can always ask a question in the Q&A window, and then between presentations we can see if we can answer those, or you can message us on Slack, whatever you want. So yeah.
So well, thank you all for joining this this webinar, of course. Well, I will share my screen. What I would like to do today is talk to you about how we use Mendix and artificial intelligence to innovate in the healthcare industry, specifically in the area of creating rosters for nurses and other personnel in hospitals. This is based actually on a case we are doing for 2 companies right now. And I think it's pretty interesting stuff. So what we see in general, this is our philosophy when we talk about these kinds of cases, is that many companies are struggling with effectively creating a planning. So this can be a planning on for example, when do I let my nurses work, but it can also be how do I schedule tasks on my production lines, or how do I send my field service engineers into the field. So many customers are struggling with effective planning. And we see many companies, such as Ortec, for example, having a planning engine and try to solve that puzzle. However, our philosophy is that when you talk about planning, you talk about more than just efficiency. You're also talking about facilitating people in doing their daily tasks. You want to give them insight in what they need to do, how they need to do it. So it's much more than just efficient planning. It's also about having attractive, useful applications, integrating them with other software, such as an ERP, and making all of this information available, for example, offline on mobile devices. So this is why we love to use Mendix for these kinds of problems, because with Mendix, of course, you can create much more rich applications, and it's not only about having this planning piece. So what we do, we combine 2 worlds here. We have our own planning engine, it uses artificial intelligence, but we combine that with Mendix, because when we position Mendix on top of our planning engine, what you will get is a very flexible application layer, which is really able to work on mobile devices, to look nice, while at the same time you can leverage artificial intelligence in the backend and let a planning engine solve these complex puzzles for you. Furthermore, we use also Mendix, of course, to do third-party integrations with other systems. So for us, it's really about combining these different technologies and creating an application which is fairly complex, solving a complex problem for our customers in an efficient and agile way. So what you're about to see, I'll give you a demo shortly, is our smart rostering solution. Before we go there, and I would like to briefly explain, if you look at the previous picture, these 2 different layers. So on the one hand, we have the application layer, which is Mendix here, and besides that, we have the planning engine, which works in the backend as a separate microservice. And what we do with Mendix is all these, basically the core USPs of Mendix, right? It's about having good, proper UI UX. It's about integration. It's about being able to show your planning to external users, not only your own employees. It's about customer-specific workflows and all those kinds of things. Of course, Excel integrations for exports and imports. We all often hate them. We see them being used often still. And of course, fine-grained security. All these things we do in Mendix. What we do on the back end in the planning engine in a separate microservice is we use AI. So we have very complex algorithms optimizing this planning puzzle, which I will show you shortly. We have rules, all of those kinds of rule sets, which determine the most efficient, optimal planning. And we have full support for automating this. So you can just tell the planning engine, this is my planning puzzle, solve it for me, evaluate millions of combinations, give you back a optimized result. This is what we do in the backend. So there's a clear distinction between what we do with these different technologies. And then what you see here at the bottom is you've standardized all of these rules and this planning engine to a high degree, because you can imagine this is costly to build. There's months and months of work to build stuff, or even more to build these kinds of AI engines. But once they work, all the customization, we do that in Mendix. So every customer of ours, they have their own Mendix application, which is highly customized, but they leverage the same planning engine capabilities. So this is why we love Mendix, because we can quickly customize here on a case-by-case basis, while still leveraging our standardized artificial intelligence rules. And this is kind of the way we see many solutions evolving. You have some standardization in the back end, and with Mendix, you customize all of it towards your customers' needs. This is how we look at templates, for example. So if you look at the architecture, because we're still techies, right? We love this stuff. What you see here is the architecture of such a landscape for us. So it's all centralized around Mendix. So our end users, the actors, the employees, which gets a roster assigned to them, or shift, the planners who make these assignments, they all work with the Mendix rostering application. So this is what all our users interact with. This is what we customize. This is what the customer sees. But behind the scenes, there's an entire world going on, which runs somewhere in the cloud. And these are microservices, and what they do is, here is the place where we solve the planning puzzle. So in your roster application, you have your employees set up, you have the availabilities, you have the shifts that you need to do, the skills people have, all those things, all the ingredients, all of that you manage here. And once you want to say, give me the planning, we do a call to this API. There's a load balancer, of course, in between, which passes it through to our high available planning API. And then what we do, we store the planning puzzle in a database, and we have a Kubernetes cluster full of planning engines where all the AI happens. So this thing will automatically scale up and down depending on how many open puzzles we still have in here. And based on that, we can fairly quickly, in a matter of 1 or 2 minutes, return back a result. Well, we can evaluate many different plannings at the same time here, evaluating millions and millions of possibilities. We still are able to quickly give back the optimized roster, all the notifications we see. For example, you have too few employees, or people are working more than they should based on our employee contracts. All of those things are determined here, sent back to Mendix, or we visualize it to the end users. So here it's all about workflow, about visualization, about third-party integrations if that's necessary. And here it's all about AI and planning complexity. That's how we kind of split it up, where we standardize this and are very flexible and agile here. So that's our world. That's what you're about to see in a few minutes. So why do we do this? Well, like I said, many of our customers are struggling with a limited set of resources. These can be employees, these can be assets like production lines, physical machines, also be time or money or space. Everything which is constrained, you can optimize in the planning engine. And one of those planning cases, the one we're talking about today, is creating shifts for nurses. And our engine is capable of handling many different cases. So we're talking about nurses today, and I'll give you the details later. But we can also optimize field service engineers. We've done it for a few other customers. We can do stuff around vehicle routing or production line scheduling or planning. So there are many different use cases, or many different, in computer science they call this resource constraint puzzles or problems. You should look it up. It's a very interesting mathematical problem actually in computer science, which has never been solved fully optimal until this point. But our engine can work on all of these things. And what it does is that while we can solve this in the backend, we use Mendix to handle all of these use cases. So give me 1 second because the music is playing for some reason. Sorry for that. So we have a few core concepts in our rostering engine for the nurses, and I will outline them here before you see them. First is, of course, we have employees. So these are the things, the resources for which you actually create rosters. Secondly, every employee has a contract. So how many maximum hours you work per month, for example, is set up there in Mendix. Then each employee has a mobile application on his phone, using Mendix, of course, where he can log in, or she can log in, and then they can say, well, I'm unavailable at this time, or at this date, or I really would like to work here, or I'd rather not work there. And the engine will balance all of these availability requests out to make a fairly nicely balanced shift roster. All of this is done on mobile phones. Then skills. Every employee has a skill set. So you need to have the proper skill to be able to work, of course. Furthermore, we have shifts. So this is the actual thing to which you want to assign an employee. So every nurse, they go to the hospital and they have to work in the morning or the afternoon, or of course also during the night. And right now with Corona, we see on the ICUs, for example, they need more nurses during certain time periods. And all of that needs to be balanced out. So the shifts is what we're actually trying to assign to employees. This is where the planning puzzle really is. Then we have spots, which are basically the departments in the hospital. So you have many different, of course, let's say, business units or departments, and not everybody can work on the same department. That's taken into account. We have a rotation. This is what we call a shift template. So every week or every month, you have this set of day, night, weekend shifts. You don't want to create them by hand every time. So you have a shift template, you import that, and then you try to optimize the planning. And of course, you get all the history. So this Mendix application is going to contain a lot of data, because over time, you need all of this historic data because it influences the rosters you will make in the future. For example, in the Netherlands, there is a law which says you can only do 30 night shifts, I believe, per 3 months, something like that. So you need to keep all of this historic data, send it to the planning engine, because it needs to take it into account, because of course you cannot violate these rules. So about the business rules, we have many. Of course, for every shift, you need to have the proper skills. Employees, they must be available. So if you are on holiday or sick, or you have a fixed day off every week, like your daddy day or something, this is also configured in Mendix, and the planning engine takes into account. And there are many other rules, like you should only have 1 shift in 24 hours. Between 2 shifts, you should have at least a certain amount of hours of free time. You need to respect the contracts of people on various time periods. We have many laws and rules in the Netherlands which we need to take into consideration. All of those are configured in our planning engine. So Mendix doesn't even have to know them. They just have, for Mendix, you just send the planning puzzle and get back the result. But these rules live in the backend. The previous things were hard constraints. So if you violate them, you're basically breaking the law or breaking a very important rule. Now you have medium constraints, which basically is, please try to assign every shift. That is less important than hard constraint. We'd rather do not assign somebody instead of breaking the law. And then we have soft constraints, and these are the constraints which the planning engine tries to optimize. So you have, for example, employees saying, I'd rather not work on this day, or I really like to work on that other day. The engine tries to respect this, and of course gets a solution gets assigned bonus points, or is valued more if it satisfies more soft constraints. But as you can understand, they are soft, and you cannot satisfy them all. So the engine tries to balance this out. This is where the complexity comes from, because it's fairly easy to say you want to make sure nobody works at the same time, but it's really hard to balance out all of these soft constraints in an equal manner. So there are many of these soft constraints which we take into consideration. So I can talk about this for hours, but let's go to a demo. This is the Mendix app which you see here. When we log in, you get to see the tenants. So here we go. When I log in here, the first thing it does, it asks me to pick a tenant, because this Mendix application, it's set up as multi-tenant. So, for example, one of our customers, they have a set of different companies, a group of nurses, another set to a group of companies who are call centers taking calls for these healthcare institutions. And all of these different companies, they have different rules and different sets of resources, different sets of employees. So what we do here, we split those up in tenants, so they do not interfere with each other. So if you go to the hospital where the nurses work, you see here now the planning. It's still empty, and I will show you in a bit how we can set up a roster here. But here on the top, you see all the ingredients. So you do see the skills here. Then we have 2 skills. You see the spots, so all the departments, and for every department it is specified which skills you need to work there. We have some employee contracts here, sure. We have some employees set up here, actually a lot of them, I think like 100, with the associated skills which they have. So this can be based, for example, on certifications you have or degrees you may have. And the engine also evaluates all of this, including their contracts. We have availability. So every employee, for example, this lady here, Amy Cole, she can specify when she wants to work. So she wants to work here very much so. She'd rather not work here. You can also say, well, here I'm really unavailable because maybe I need to go to the doctor, for example. Of course, you can also have recurring configurations here. We won't do that now. Oh wait, still save this one. The engine will receive all of this information, try to optimize the planning accordingly. So every employee, of course, can have these availabilities. They would themselves typically set this up on their mobile device. So the employees usually won't see all of this. They just see a calendar on their mobile device, and that's where where they see their own roster, and they configure their own availabilities. But as a planner, which I am now, of course, I see everything on my desktop because I want to have the full overview. Then the rotation. In this demo, we have a rotation for a week. What this means is this is actually my template. So every week I have this kind of situation set up for the anesthetics spot or department. So I have a morning shift until 2 in the afternoon. I have an afternoon shift, and then I have a night shift. And I also have a day shift that somehow overlaps a little bit with the other shifts. And these are actually all the shifts which I need to assign to employees. If you open such a shift, you will see that there also is a preferred employee that one's configured here. That means that from a, for example, team lead perspective or hospital perspective, I can say, I really would like Amy Cole to always work in the morning because she's such a cheery person in the morning and she isn't cranky in the morning, for example, right? So you can configure that here. Of course, you see here that Amy Cole is requested every morning. Of course, that cannot happen because that's much more hours than her contract allows. Also, you would violate quite some laws if you would let somebody work 7 days a week, at least here in the Netherlands. So, of course, the engine will not assign Amy Cole to all of these shifts. Well, hopefully, at least, we'll see that in a bit. But that's how this works. And for every spot here, for every department, you see that we have a roster template set up here. Of course, you can create your own shifts here as well. And you can also create much bigger rotations. For example, you can also say, I want to plan in blocks of months. So I have all these months set up as a template. So now let's do the exciting bit. Let's say we want to do a new planning. What we first do is we import the template. So what we call the rotation. Let's start on Monday next week. And let's just do the import. Sure, why not? And what it does now, it creates all these empty shifts. We're in the next week, I hope. Yeah, here they are. And nobody is assigned to them. So yes, we have a preferred employee. Remember what it was? I believe it was Amy Cole here. But she's not assigned yet because we did not do a planning run. And once I push this button here on the top, what happens is now we grab all the information in Mendix. We gather all the employees, the contracts, their skills, all the spots, hundreds and hundreds of shifts. We combine it all in one big API call. It's being sent now. Remember the architectural picture. It's being sent now to the planning engine. It will scale up some engine capacity in Kubernetes cluster. It will try to solve it, or at least optimize it as much as it can. I think we are now giving it like 2 minutes or so to evaluate millions of different combinations. And then it will return a optimized planning. And it will also give some warnings, like, for example, this employee is now being assigned to this task, but she was not the preferred one, or she actually was unavailable, or she did not really want to work. So it also calculates out all kinds of scorings. As you can see, it can take quite a while before it gives a result. Here we are. So here you see Amy Cole. It was a nice example. She was preferred always for the morning shift. You see here these lighter greens. The engine decided to assign Amy Green and Amy Jones, so not Amy Cole. So this is why these blocks are lighter green. The darker green here, when we click it, you also see here there's a dark green thing. It basically says, well, you've done a good job. I awarded you an extra point because you assigned the preferred employee. So that's why this has a better color. Here we have an orange color because it's interesting. We violated the rule here, but we also assigned the preferred employee because Amy Cole was the preferred one, so we get a plus point. But we also get a minus point because, as you remember from the availabilities, she indicated she'd rather not work at that moment in time. But the engine evaluated all kinds of other employees for this task, but some were not available maybe, or also didn't want to work, or it was better to assign them to a different spot because she had other skills. So in the end, the engine decided that although she didn't want to work, it's still a good idea to assign Amy Cole here. And what you saw is that in a few minutes, I think it was 2 or something, he quickly created this entire planning. So also for every spot we have done this. So you see here all these rosters being created. So you can imagine if you would do this as a human, it would have cost you a lot of time to manually assign all of these people to all of these shifts, especially if you would have to manually take into account all of these different laws and rules we have lying around here. What's further interesting in Mendix, of course, is we have this calendar widget here. So we now have only planned 1 week, so you can see it here. That's pretty nice. But we've also been experimenting with different views. So this was a calendar view, but you also have what we call a planner view, where you have a different image of the situation. For example, if I would look at the critical care unit, ideally, it will show you. If I go to the week mode and I go to next week, it will show you who is working when in a different view. You can also, of course, do it on the day level, and I have to navigate to the 11th. I think that's the first day where we had some assignments. And then the day further, and then you get to see who is working on which shifts in a different way. And if you do this for all spots, it will show it all underneath each other. And what we've learned is that from different customers and different roles in these hospitals, they have different preferences actually on how they want to look at the data. So with Mendix, we have been using these different widgets to show the same data in different ways for different target audiences. And I think this is one of the very strong points of Mendix, because we have these widgets, and nowadays we have React, where we can ourselves build many flexible things. And then we have one unified source of truth, the Mendix database, the application there. But with these widgets, we can visualize data in many different ways. Also on mobile devices, and I think this is really a strong argument for using Mendix over, for example, completely SaaS solutions where you may have less flexibility in customizing all of this. I've been playing around with different visualizations all over the place, because we think it's pretty valuable to be able to show this information in all these different capacities. The last one, which may be interesting, is this one, where we just show it all in a grid, where you can quickly see, based on the scoring, how good or bad is your planning. So this is normal, and the row is better, and then we get to see if we're still doing okay. You see the one where we violated one of the rules. And this, now what you can do is, as a human, you can still say, well, I really know Nicole does not like to work this day. I can delete her. I can assign another employee. Take her away. I can assign another employee, and I can even say pin it, this button here. And once I do this, the planning engine will respect this action. So the AI will now calculate around this custom action I did, and take into consideration that Amy Smith really is supposed to work on this particular shift, and then the planning will be optimized around my manual override. So we can force the AI to take different decisions by configuring the shifts differently in Mendix. So what it does now, by the way, is recalculate all the scores to see if what the new planning should be. So this is fairly quickly what I can show you today, how we use Mendix in combination with AI to solve such a planning puzzle. What I want to do is quickly go back here. There we are. So, if you look at development highlights, one of the things which is interesting, I think, with this project is that we've used AI to evaluate these millions of possible combinations with this dedicated planning engine. This one is implemented in Java. Like I said, it runs as a separate microservice, or actually set of microservices in the backend on a Kubernetes cluster. We've combined this with Mendix, and one of the things, like you've seen, is the customization we can now do with React and Mendix. We can make really cool widgets or reuse what's already out there in the React community to be able to visualize this data in different ways. And I think that's a really strong argument to use Mendix here. Secondly, what was interesting for our developers is that we have been working hard to improve performance. We're not there yet at all. But for example, the REST integration with the planning engine is fairly complex. The REST requests and responses going off the lines are huge. And our guys have been working hard to improve that. Doing some custom queries, for example, and creating JSON in such a way that we do not necessarily need the Mendix abstraction layer everywhere, because it can be fairly slowish if you have huge data sets. And we have worked on this clever module separation, because what we do is we'll build these types of applications as templates, and we customize them for every different customer we have. But what we did is we have some kind of microservices approach towards our components or modules in Mendix. So in the Mendix application, you will see many different modules with this idea of making sure that we can customize, for example, only one screen without having impact on anything else. So this allows us to really be fine-grained in what we customize and what we keep the same. So once we have our customers buying this and they start to customize certain specific things of the application, we can still upgrade the other things, the other modules, where we may apply bug fixes or new features, for example. This is also, I think, fairly interesting. So to summarize quickly, because otherwise Martin will be angry at me, we have this customizable user interface with Mendix. We provide mobile device support. I haven't shown this yet, but most of you in the call are Mendix developers, so you know how it works. For example, the calendar, which is also pretty nice on your mobile phone, will kind of give you the Google Calendar feel where you can see when you have to work and when you don't. We have easy integration with other tools, because in practice, our customers always want to integrate this with something else. For example, an hourly registration tool, or maybe some kind of financial system where they want to, for their administration of the salaries, where the rosters play a role. So with Mendix, we always customize this per customer. And as you know, integrations are fairly easy with Mendix. And this is where it really shines, because you have all out-of-the-box capabilities which you've just seen, but with custom integrations with your backend landscape. And finally, we can add customer-specific planning rules. This is mostly in the backend. We have different rule sets there, which you can enable or disable. And in Mendix, then you can configure which rules you want to apply in the backend. I think that's pretty advanced stuff, wasn't easy to build. But it's really cool because it allows us to use one planning engine from a technology perspective, deploy it in many different situations, and use Mendix as the layer of also configuring the engine, which makes it really fast for us to be able to deploy and onboard new customers in this setup. So, because due to time, I would like to see if anybody maybe has some questions.
Yeah, thanks for that, Jethro. It's very good. Oh, I can hear myself through your through your PC.
Yeah.
So we have a couple of questions actually. Let's go through some of them. So Jason's asking, what was the unsolved mathematical problem that you mentioned? Something about planning.
Well, it's yeah, for planning. Well, if you look it up on Wikipedia, because it's still unsolved in that sense, it's a constraint resource problem. And what it means is you have all of these constraints, these business rules, and there are many of them. And so this means, it's a bit mathematical maybe, it results in this multi-dimensional landscape with millions of different possibilities. And there is no mathematical way of knowing for sure that your current solution is the best solution. So you can imagine, if you look at it, and what it does, it calculates a possibility, it gives it a score based on all of these business rules. For example, we'll score maybe whatever, an arbitrary number, 10. Then it calculates a different score, and maybe 11. So you think, well, I'm on a good path here, this is better. And you go to 12, 13. And the next solution may go down again in terms of scoring, so how good it is. And then you get the question, is the short 13, which I've just seen, is that the best solution you can do, or is there also a 15 somewhere? You don't know this because you cannot calculate all the combinations in a finite amount of time, because there are millions and millions of those combinations. So the closest you would,
so the closest what you'd be able to get is a probability in that case?
Yes, exactly. The closest is that you get the probability of an optimized solution. And what we do with the AI, we have these algorithms there to, for example, prevent that you are getting stuck in a very a bad situation. So if the scoring is kind of going up and it goes back down again, maybe you need to go further down to find a new top, right? It's like if you cycle on a mountain, when you cycle up, you think the thing you are looking at is the highest mountain, but we're on the top, there may be higher mountains after it, or there may be better solutions, but you don't discover them when you go down in the valley again and try to climb the next hill. So we have some things in place to make sure we kind of do not get stuck in a suboptimal optimum, if you will. What we also do is, one second again.
And Jethro disappears.
Yeah, sorry. What we also do is we try to make sure that we do not go searching too long for these answers. You cannot have the engine running for 6 hours and the customer waiting. So we also play around with many different strategies and algorithms. And then we say, well, for example, stop searching for a better solution once we have not seen a improvement of a certain percentage within the last 30 seconds or within the last 500,000 attempts. So you have all these kinds of ways of balancing out and saying these are the stop conditions. At some point, you have to stop searching. There may be a better one, but it may take you an additional 8 hours to find it. Well, this one is good enough as well. So you have to play around with all of these kinds of settings in the AI to optimize your solution finding.
Yeah.
So look it up. It's really interesting. On Wikipedia, there's lots of content about this.
Yeah. So we have a couple more to go. So I'm hoping that, considering time,
I'll do it quicker.
Yeah, we can. No, don't get me wrong. I love an elaborate answer, but I also want to respect people's private time.
Sure.
I think Martin's gonna look at the next question.
Yeah, I think we can do one more, Jethro. Just a quick one. The question is, what kind of widgets are used for these planning views?
That's a good one. They're based on React. Well, we can maybe afterwards share which direction these are. There are two specific ones. One is the calendar view, where you basically kind of have the Google Calendar view, and the other one was the planner with the horizontal bars. React, I think it was React Scheduler or something. It's also on GitHub, and I think there are also App Store modules for this. If you search on calendar or planner, we did do some bug fixes and performance improvements internally, and added some features to, for example, allow for better drag and drop capabilities and stuff like that. I think it was React Scheduler, the name. But maybe afterwards, if the slides are shared, we can also share this information.
Okay, thank you. And thanks for this interesting presentation. It's definitely something that is applicable for lots of industries and stuff.